Mathematically, you should not exist. Neither should the screen you are watching this on, nor the planet you are standing on. Standard particle physics predicts a cosmos filled entirely with expanding photons and massless energy. According to the baseline models, the universe should have no solid structure. Reaching a stable, material reality required the early universe to thread a needle through a sequence of unimaginably narrow mathematical constraints, all within the first second of its existence. We can map this sequence as the cosmic filter. To produce physical reality, the early universe had to clear three absolute mathematical prerequisites: topological dimensionality, expansion fine-tuning, and the baryogenesis glitch. Every star, planet, and biological cell is the physical byproduct of surviving three devastating mathematical failure states. Before physical matter can exist, the universe must mathematically derive the concept of space. In mathematical logic, space functions purely as a measure of betweenness, a dimensional framework where objects exist relative to one another. Starting from a dimensionless point, mathematical sequence forces an expansion. One number implies a sequence, fitting between other numbers, mandating an expansion into 1, 2, and eventually multiple dimensions. To create stable matter, the universe requires topological stability. Particles act like knots, needing strings to cross and bind. In four-dimensional space, this fails. Strings have too much room and phase past each other. But 3D space forces them to interact and pull tight. Once this 3D environment is set, particles are bound by the Pauli exclusion principle. This dictates that no two identical fermions can occupy the same quantum state simultaneously, creating the foundation for solidity. The three-dimensional universe acts as a strict algorithmic requirement that prevents matter from unraveling. Once stable particles form in 3D space, the universe hits its second filter. The kinetic energy driving these particles apart must be perfectly calibrated against the inward pull of gravity. Cosmologists measure this expansion rate using the Hubble constant, which dictates the exact strength of the initial Big Bang explosion. To yield a physical universe, the initial expansion required an accuracy of 1 part in 10 to the 60th. Tuning below this, gravity overwhelms expansion, collapsing everything into a singularity. Tuning above, the universe expands so rapidly that matter is completely torn apart. To grasp this precision, imagine firing a bullet and hitting a 1-inch target located 20 billion light-years away, on the opposite side of the observable universe. Other parameters face similar constraints. The strong nuclear force requires a variance of less than 5%. Outside that window, nothing other than basic hydrogen can exist. The Big Bang was a highly orchestrated expansion, balanced exactly on the edge of immediate failure. These physics played out during the quark-gluon plasma era. This period existed mere microseconds after the Big Bang, operating at extreme density and temperature. Facilities like the relativistic heavy ion collider at Brookhaven National Laboratory physically recreate these exact conditions today. The foundational law governing this era is balance. To maintain stability, basic properties like net charge and angular momentum must be strictly conserved. Noether's theorem dictates the consequence of this balance. Whenever energy converts to matter, the universe must produce an equal and opposite twin, antimatter. Matter and antimatter possess the same mass but opposite electrical charges. They are destined to destroy each other upon contact. In the chaotic quark-gluon plasma era, billions of matter and antimatter pairs emerged, only to instantly collide and annihilate into pure radiation. This creates what physicists call the annihilation paradox. If the universe perfectly obeyed its laws of symmetry, 100% of matter would have been destroyed instantly. Strict adherence to the laws of physics results in a completely dead universe, filled only with microwave background radiation. For us to exist, those laws had to break. The solution to the annihilation paradox is found in baryogenesis, a process that allowed a fraction of matter to survive. Physicist Andrei Sakharov formalized the conditions necessary to break the universe's symmetry and create an imbalance between matter and antimatter. Sakharov proved the universe had to operate out of thermal equilibrium and violate charge parity, or CP, symmetry. This CP violation acts as a glitch in the cosmic machinery. Briefly, the universe failed to treat matter and antimatter with perfect equality. Look at these probability curves for the decay of particles called kaons. In 1980, experiments observed a microscopic discrepancy where the probability of matter slightly overtakes antimatter. Because of this probability glitch, the decay processes occurring in the early universe produced more baryons, or normal matter, than antibaryons. The margin of this asymmetry is staggeringly small. For every 1 billion particles of antimatter created, the universe produced 1,000,000,001 particles of matter. Our material reality is the leftover residue of a minuscule mathematical rounding error. Matter survived an impossible gauntlet, crossing the topological threshold of 3D space, surviving the razor's edge of the expansion rate, and enduring the great annihilation. When the annihilation phase ended, what remained was a vast dark void. Almost all mass had vanished, leaving only lone blue particles, the 1 in a billion survivors, drifting in the darkness. Every piece of antimatter was destroyed. The cosmos was reduced to a sea of photons, sprinkled with these rare surviving particles. As the universe cooled and expanded, these sparse particles aggregated and initiated primordial nucleosynthesis, forming the very first atomic nuclei. Those primordial nuclei aggregated into the cosmic web, ignited the first galaxies, and forged the carbon chemistry required for biology. Perfection and absolute symmetry yield nothingness. We exist solely because the universe is flawed, making humanity the product of a vital, terrifyingly improbable mistake.